Welcome to Homework Lib.
Hi, so for this question, we're considering the dissociation of an organic acid. I'm going to abbreviate that directly as BH, as being any general organic acid, in aqueous solution that is going to dissociate into B minus plus H3O plus. So in order to know the percent of dissociation, what we're going to do is, let's consider an ice table. Let's begin with our initial concentration, the amount of change, and the amount of equilibrium. The initial amount that we're going to have, this is going to be C0, and C0 in this problem is 0.0883 molar. The amount that is going to dissociate, let's call it X, so an X amount is going to be generated on both sides. So at equilibrium we have C0 minus X, X, and X. And X is going to be the amount ionized or dissociated. Okay? So with this, our acidic constant for this acid is going to be the conjugate base times the concentration of H2O plus divided by the concentration of BH. This turns into x squared divided by C0 minus x. Okay? So now we are going to do an approximation. Here we could solve directly the quadratic expression that comes from replacing the value of C0 and Ka and solving for x on this side. But the approximation that in most cases is going to work is that C0 minus x is approximately the same as C0. And this condition is true when the percent of dissociation is approximately less than 5%. The percent of dissociation that we found under this. Okay? So, with that assumption, the equation now turns into x squared divided by C0 is going to be equal to Ka. This is the approximate solution. So the value for x is equal to Ka times C0, taking the square root. For our case, this is the square root of 1.38 times 10 to the minus 4 times my initial concentration that was 0.0883, and the value for x that we found is 3.49 times 10 to the minus 3. Now, if we compare that value to my initial concentration, you're going to realize that indeed it is going to be lower than 5%. So that approximation is valid. So now, in order to know the percent of ionization, it's going to be equal to the amount that is ionized, which is going to be our x, divided by my initial concentration times 100. So the amount ionized is 3.49 times 10 to the minus 3 molar, divided by C0, which was 0.0883 molar, times 100. Which gives us a value of 3.95%. 3.95% of ionization. Now, if you're curious what would be the result if I solve directly the quadratic expression for x, the result would be 3.42 times 10 to the minus 3, which would give us a percent of ionization of 3.87%. So as you can see, the difference in the percent of ionization for solving the full quadratic expression and for solving the result with an approximation, it is not going to change a lot as long as we are below 5%. If we are with a value higher than 5%, then we can no longer use our approximation, the equations in red, and we need to solve directly the quadratic expression. And that would be all.